Understand MapReduce flow. Let's take an example to understand MapReduce flow because we are moving computing to the data. Let me give an example to understand the MapReduce flow. Now we have a file. The file that we code in this is this. File content is London 20 May, Paris 25 May, Pune 30 June, Sydney 33 Feb. This is my file F1. This file is a sample file that contains weather information for cities and months. Now file is split into two parts S1 and S2. Now my MapReduce job is what is the weather of London? I need to find out the weather of London. Okay. Now I am using this as my job J1. Job is submitted to job tracker. And now this is split into the task T1. Let's say this task is given to the task tracker. Okay. Now let's for simplicity assume there are two data nodes. Data node 1 and data node 2. Now let's assume this file is stored here in D1. This is split 1 S1 and split 2 is stored in data node D2. Now job tracker knows this task needs input of which file we need. F1. Where is the F1 residing? Where is the F1 residing? In data node D1 and D2. And job tracker knows F1 residing in D1 and in D2. So it schedules a task TT1 in both D1 and D2. So that it can execute on that machine. This is how this task T1 moved closer to the data so that the computing is performed locally without moving the data. Understood? Now my question is, how job tracker knows which all data nodes have the file? Let's look at the scenario. We had job tracker, we had task tracker TT1 and TT2. Now we also have data node DN1 and data node D2. We have a name node. Assume data node D1 got the split of file S1 and D2 got the split of file S2. Now when a job is submitted to job tracker, at least the job says input file F1 is needed. So job tracker will query to the name node where is the location of file F1. Now what does name node do? What would name node do? Name node is managing the data nodes. What it would do? It will tell this location. Name node has an image which says F1 is in all data nodes D1 and D2. Right? Now when it knows these are data nodes it has got, name node will do something called pipeline. Name node will form a read pipeline and return read pipeline to job tracker. So now the job tracker knows this is the pipeline and the pipe constitute of D1 and D2. So it can schedule the task on D1 and D2 with pipe ID given. Okay, so it's scheduling at D1 and D2. Here job tracker is a Java process, name node is a Java process, task tracker is a Java process, data node is a Java process. All are Java process talking to one another. Client, when we say, is an external entity to the Hadoop world. Client could be a Java process, it can be a SQL query, or it could be a web service, or it could be an ETL processing job. Okay. Now this is how the job should get scheduled. Closer to where data exists on the cluster That's why Hadoop is more magical to the work on big data domain without moving the data. Okay.